Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2019, 10B, Problem 16, and it deals with geometry. I hope you guys enjoy this video and let's get started. The problem states, in triangle ABC with a right angle at C, point D lies in the interior of line AB and point E lies in the interior of line BC, so that AC is equal to CD, DE is equal to EB, and ratio AC to DE is equal to 4:3. What is the ratio of AD to DB? So the best way to start off this problem is to draw out what we're given. So we know that we have a right triangle. We know that there is an angle at C, and I'm just going to let this be A and this be B. It tells us that point D lies in the interior of AB, so it lies on AB, and then E lies on BC. AC is equal to CD, so I'm going to let this point be D, so that AC is equal to CD. And then DE is equal to EB. So these two are the same. And then it tells us that the ratio of AC to DE is 4:3. So I'm just going to let AC be 4 and then DE be 3. It's asking us the ratio of AD to DB. Well, I'm going to start off with setting up some angles here and see if we can use similarity triangles to figure out some information. So I'm going to let angle A just be alpha and then angle B be beta. Angle B, so beta is equal to 90 minus alpha. And then because triangle ACD and triangle DEB, these are isosceles, and that means that angle CDA, this angle right here, is also equal to alpha, and this is beta. Well, and that means that angle CDE, so this angle right here, or let me change the color. So this angle right here, that is equal to 180 minus alpha minus beta, which is equal to 180 minus alpha minus 90 plus alpha, which is just equal to 90 degrees. So we see that obviously it's not drawn to scale, but this is a right angle. Well, because that is a right angle, then we know that DE is 3 and then CD is 4 because they're isosceles triangles, and it's a right angle, then this is a 3, 4, 5 triangle. So that means that CE is equal to 5. And then we also know that EB is 3 because, again, these are isosceles triangles, so DE and EB are the same. That means that CB is 8. Well, we now know the two legs of this right triangle, so we can use Pythagorean theorem to figure out the length of AB. So AB is just equal to the square root of 4 squared plus 8 squared. And this is equal to the square root of 80, which is 4 square root of 5. So AB has length 4 times square root of 5. Okay, now I'm going to draw some altitudes. So in the isosceles triangle ACD and DEB, I'm going to draw an altitude from C to AB and from E to AB. So this is what we get. And so these are right angles. And then I'm going to let this be PC, so point C, and then point E, just to make it a little bit simpler. Now we see that there are some similar triangles. So we see that triangle ACPC. So triangle ACPC and triangle ABC. These are similar because of angle, angle, angle. So we see that this is a right angle, which means obviously this is a right angle, and then they both share the angle alpha, and they both share the right angle, so that means that automatically the third angle is also the same. So because we have this similarity, I'm going to use some ratios. So because ultimately we want to find out AD and DB, so I'm going to set APC to be x. So x over what it corresponds to, which is AC, which is 4. This is equal to the hypotenuse, which we know AC is still 4, over the hypotenuse of ABC, which is 4 times the square root of 5. So this would cancel out. X times the square root of 5 is equal to 4, so x is equal to 4 over the square root of 5. And then we could do the same thing with D and PE. So triangle DEPE is similar to triangle BAC. And the reason why I wrote it like BAC instead of ABC is because it's easier for us to find out the ratios. So I'm going to set DPE to be y. So y over BC, which is 8, is equal to the hypotenuse DE, which is 3, over the hypotenuse of ABC, which is 4 square root of 5. Okay, so here's what we get. We get DP is equal to 6 over the square root of 5, and then APC is equal to 4 over the square root of 5. And so that means that we can figure out AD, which is just 2 times x, because this is also x. So it's just 8 over the square root of 5. And then DB is equal to 2 times y, which is 12 over square root of 5. And then ultimately we want to find out AD over DB, which is 8 over the square root of 5 over 12 over the square root of 5. And so that's just equal to 8 over the square root of 5 times square root of 5 over 12, which is just 8 over 12. And then we can simplify this down to 2/3. So the answer is A, 2 to 3.